Hey everyone! In today's video, we're going to learn how to implement the ability to reach out and grab things at a distance. On my right hand, I'll reach out, point at the pistol, I can hold grip, and then do a flick, and now I have pistol in my hand, and I can shoot it. Oh no, it fell. On my left hand, I can point at it, hold the grip, pull the trigger, and it'll smoothly interpolate over to my hand. So I have two different styles of being able to reach out at range. Let's take a look at how I actually accomplish this in code. Starting in our ranged grab target class, it's actually pretty straightforward. We have a serialized field for a transform target indicator, which is the transform of the sphere that was showing up over the pistol. And it's also got a grabbable field so that when the grab is concluded at range, we can pass that to the grab manager and activate any normal grab functionality that would exist. In our start, we're going to make sure that the target indicator is off, and then we have a target method that's public, which just sets that target indicator to active, and on untarget, set it to inactive. Over in our ranged grab detector class, it's a little bit more difficult. We have a require component for type of grab manager, since the grab detector won't work without a grab manager. We have two serialized fields, one layer mask for our ranged grab layer, and one float called detection range, which actually controls how far out we can detect ranged grabbables. We get a private reference to our grab manager, and we have a public ranged grab target, active ranged grab target, so that when our ranged grab activator is working, it can actually pass the target to our grab manager to activate any grab features. In our start, we'll just get a reference to our grab manager, and in our update, we determine if we have an active grabbable. We won't do anything, because if your right hand is already holding a pistol or any other grabbable and you point at something that it can grab, we don't want to highlight it as grabbable since you're already holding on to something. After that, we do a ray cast out from our hand's position going forward up to detection range on our ranged grab layer. With that hit, we check its collider if it has a ranged grab target, and we specifically check collider instead of transform because Unity's collision system, if you checked for transform, it's always going to return the parent, which might not be what you want. So you can check the collider, which is the actual collider that was hit. If we have a ranged grab target and our ranged grab target that we're checking against and is not the one that we're actively already focusing on, then we say, hey, if active ranged grab target is null, we're going to untarget it so that that indicator goes away, and then we assign active ranged grab target to the ranged grab target that we're testing against and call its target method so the indicator is enabled. If that raycast failed, but we have a ranged grab target currently, we'll call untarget and assign it to null. That way, if we were pointing at something and moved our hand away, the target indicator goes away. And the last method at the bottom here is a has active ranged grab target, which just determines if the detector is actually focused on something that has a ranged grab target on it. Our ranged grab activator class is probably the most complicated class out of the three. It has two required components, one for a type of grab manager and the other for a type of ranged grab detector. This class won't function without either of them. We also have four serialized fields at the top, a bool flick activated, a float flick begin threshold, and a float flick end threshold, and a ranged grab duration. Flick begin threshold and flick end thresholds are the angular velocities that need to be broken and fallen under for that gate to flip. And our ranged grab duration is when the ranged grab is performed, how long it actually takes to transfer from its position to the player's hand. We also have some private references, one for the grab manager, one for the ranged grab detector, and one for our active ranged grab target. We also have a bool for if we're executing a ranged grab, and a bool for breaking the threshold. In our start method, we'll get a reference to our grab manager and ranged grab detectors. We will set up our grip triggered and grip canceled notifies for our hand based on the grab manager. And then we say if it's flick activated, we register an input notify for the angular velocity of the device. And if it's not flick activated, we register a trigger for the triggered notify. In our handle grab triggered, we check to see if the grab manager doesn't currently have something that it's already holding. And if our ranged grab detector has something that it is actually focused on, we'll set our active ranged grab target to the ranged grab detector's active ranged grab target. And our handle grip let go, if we have something that we're focusing on, we'll set it to null. And if we're currently executing a ranged grab, it'll just stop the coroutine. In our handle angular velocity change, we get the speed of the angular velocity, which is our magnitude. We check to see if we actually are focusing on a ranged grab target. We check if we broke the threshold by calling has flick begun, passing in speed. And then we check to see if has flick ended, and we're not already executing a ranged grab. We'll start a coroutine called execute flick ranged grab, and then we'll reset broke threshold. And if we didn't have an active ranged grab target from the start, we'll set broke threshold back to false. This code for the flick is heavily based on VR with Andrew's flick video. I'll link it in the upper right hand corner. I highly recommend checking out his video on the subject and all of his videos. They are very informative and a source of inspiration. Below that, we have two private bool methods, has flick begun, has flick ended. It takes in speed, and if we broke the threshold, it'll just return true and has flick begun. And if we haven't broken the threshold yet, we check to see if our speed is over our flick begin threshold. And then has flick ended, it's the inverse. If we broke the threshold, we only return true once we're under the minimum threshold. Otherwise, we just return false. Our coroutine for actually executing the flick ranged grab. At the top, we have our execution time, which we start off at 0. We have our origin position and origin rotation based on the active ranged grab target's position and rotation. Our distance that it needs to travel. And a midpoint, which will help create a nice arc effect based on our hand's position and its forward multiplied by its distance to the object with a little bit extra. And this helps create a nice arc from where it was to our hand. We check to see if the active ranged grab target has a rigid body. We'll set it to kinematic and turn off use gravity. This will help make sure that the path that it follows is exactly what we want. We set executing ranged grab to true. And then while our execution time is less than our ranged grab duration, we check if active ranged grab target is null. This can happen in the event that the user let go of the grab button while it was traveling. If it is null, we're going to break out of this. We'll then update our execution time. We'll calculate how far along our execution we are. And then we update the position and rotation. We use a calculate curved point method, taking in the origin position, the mid position, its end position, and how far along we are. For the position and for rotation, we're just going to lerp or slurp between the origin rotation and our hand's rotation, and we're going to be doing that to the percentage squared to make it a little bit snappier. Then we wait for the end of frame. If our active range grab target isn't null, so we didn't let go early, we re-enable physics, so kinematic off, use gravity true, and then we tell our grab manager to perform grab on our active ranged grab target .grabbable, and our active ranged grab target is set to null. And then at the end, we flag executing ranged grab to be false. For our calculate curved point method, we have our parameters for origin, mid, end, and percentage complete. And it's a really simple calculation. We are lerping between a lerp of our origin mid over percentage complete and a lerp from our mid to end as a percentage complete. And we're doing both of those two lerp together at percentage complete, which creates that really nice arc. If you wanted to replace this with some other arc calculation, it should be pretty simple. I find the 3-point control point arc kind of the perfect middle ground. Below that, we have our handle triggered, and this is for non-flick activated range grabbing, where if we have a range grab target and we're not already executing it, we'll start the coroutine for execute range grab. A lot of the code here is similar, but we don't have a midpoint arc that we're going to go through. So we have our execution time, our origin position and rotation. We set executing range grab to true. we disable physics on our range grab target, and then while execution time is under range grab duration, we have that same early out if you let go and active range grab target is null. We update our execution time. We then calculate our percentage complete and update position and rotation. This one is a lot simpler. We're doing one lerp from its origin position to our hand over a squared %t, and then the rotation is the same as the flick one. The reason I do a squared %t on the lerp for position is to make it a little bit snappier, since it doesn't have the same arc movement. It's just to make it a little bit better feeling for the player. We then return our wait for end of frame, and then if our active ranged grab target isn't null, we re-enable physics at the end, call perform grab using our ranged grab target's grabbable, set active ranged grab target to null, and then flag executing range grab false. And then this bit here at the end, I can actually delete. And then the change that we need to make in our grab manager is down here at the bottom is our has active grabbable, where we return if active grabbable isn't null. And that should handle all of our code changes. So I'll join you back in Unity and we can look at the mono behavior setup. Starting with our pistol object, you can see here that I have a new child called ranged grab target. It has our ranged grab target script with target indicator set to sphere, which is a child of the ranged grab target, and our grabbable points to the primary grab point. It also has a box collider that's set to trigger, and this object is on the ranged grab layer. And I've made sure that the trigger indicator sphere is off by default. On our cube, very similar, it has a ranged grab target child with the ranged grab target script, ranged grab indicator, which is a child of the ranged grab target object. It's off by default, and the grabbable is the medium cube itself, and it's also got a box collider set to trigger on the ranged grab layer. And now I can go step by step on the rifle. So I'll get a good look here. I will make a new child, call it ranged grab target. Make sure I set the layer to ranged grab, which you can add by going up here to layers, edit layers. I've set mine to layer 8. Back to the ranged grab, I can add our ranged grab target. I can create a sphere or a cube. I'll size it down, maybe a little bit smaller. On the cube, I've made this material ranged grab. It's a simple shader set to transparent, and the alpha is about halfway down with a color that I like. So I can grab that, drag it onto the cube, make sure the cube is disabled, and I'm also going to remove the collider since the indicator doesn't need a collider. I'll also add a box collider, and I'll go into isometric top down. There we go. And then make sure to set is trigger. We can exit edit for the collider. And then for the target indicator, set cube. For the grabbable, we can set primary grab point. And we can jump in Unity and check if we can range grab the rifle. Okay, back in Unity. Target indicator shows up, grab, a little bit of a flick, and there we go. Alright, we'll check back in the inspector. We have a few more things to run through for the hands. In our hierarchy, I'll select the VR controller right hand, and at the bottom here I've added the 2 ranged grab detector and ranged grab activator. Ranged grab zone layer set to ranged grab. I have it reaching out to about 5 meters. On the ranged grab activator, I do have it set to flick activated. Flick begin threshold's 1.25, flick end threshold's 1.1. Takes about a quarter of a second to complete the full transfer. And then on my left hand, I don't have flick activated set, but I do still have it taking about a quarter of a second. And that's everything you should need to know how to set up a range grab. If you liked the video, please like. If you dislike. Comment down below any thoughts or opinions, or if you have any ideas for future tutorials, and hit subscribe if you like what you see and want to see more. I've also got a Discord set up now, which link will be in the description. Feel free to join. I'll be available pretty much as often as possible, take questions, answer questions, or just talk general game dev stuff. So I hope to see you there. Thanks, everybody.